this up for the crowd. All right, and you'll plug it up.
Oh, wait, we need to be over there?
No, that's his.
I would be over
That's
there.
what he's saying
Wait,
right
I
now.
need to be over for the camera? Oh, damn it.
Camera awareness.
Oh crap. How do
Alright.
I
Minimize,
Oh.
top, left. There you go.
and then is this unavoidable?
There should be a hide button. Hide video panel. Yep.
Oh.
All right. That's fine. We're good to go.
Okay.
Now keep in mind when you do your demo, if you need to change windows, I'll let you know. So we have our first group. Let me make sure I am all prepared. Splash. All right, we're about to begin recording. Go.
Ready?
Go.
All right. Good afternoon, everyone. Our hackathon project was using the Comic Squares Science Gateway. Our team name is Llama Farmers. My name is Alan Wen.
My name's Eliza.
I'm Andrea DeMulligan.
I'm Jenny Zhao.
And we were mentored by Dr. Mona Wong. So a little bit.
Doctor.
Oh,
That's
okay,
okay.
sorry.
Thank you.
Sorry.
Thank you, though.
Wait.
Yes.
I see. I guess you have to play.
So a little bit of background on our project. The Cosmic Science Gateway was developed to assist biologists examine imaging of small specimens from cryo-electron microscopy. Here on the left, you see an example of what one of those images may look like under a microscope. And here is an example diagram of like the workflow of using the Science Gateway. So our problem was to create a new visualization application using the Cosmic Square Gateway. And our application would be used to display and manipulate different image stacks for biological purposes. And like I mentioned, most of these images would be primarily from cryo-electron microscopy. So some key features that we will be addressing with this problem will be managing and processing large volumes of images, and we will also be able to store these large data sets on the application. Another key component of our project is that this image viewer will be very user-friendly and interactive, which is super beneficial to biologists or a wide variety of researchers that don't have a lot of supercomputing backgrounds and a lot of knowledge on software. So here's an overview of some of the image stack features that we set out to accomplish. Some key features are the mouse click addition points and the deletion of those, as well as saving those to reference them for future analysis.
We were lucky enough to work off a little bit of last year's hackathon with the perk. The team was called the Cosmic Bulls. They created an HTML file that can both display the images, add necessary points, along with being able to download some the coordinates of each point, just an X and Y axis, and then being able to view them in a slideshow that goes both backwards and forwards. You can see an image of some of their work here. This is, you just plug this into Google or your other web browser. You have a small map to show what kinds of images, which image you're looking at, red dots, which are very defined, and then you can see all of the different buttons. The submit one will submit the coordinates that you had placed. There are some problems with this, so we decided to, instead of trying to rebuild their model, we decided to start from scratch. So I'm going to have Andrea take us through there.
Yeah, so we were given the opportunity to either pull from Cosmic Bull's repo, but we didn't want to be constrained to what they had. Instead, we wanted to add our own features. So this is when we're gonna start demoing now. Actually, before I do that, there are some improvements that we have. One of them, which you'll see, is improvement on the UI. So it's a lot easier for the user to navigate. It's definitely more aesthetic. We created and implemented data structure so that each image is associated with points whenever the user clicks on the canvas to put points, and that changes dynamically whenever a user clicks. In addition to the dynamic data structure, we have a dynamic list that populates the div underneath the canvas of the image so that whenever you click, it just pops right up. So you know where you're clicking at within the canvas. There are navigation arrows that correlate with your keyboard. So left means going back, right means going forward. Also, there are some use cases. So if you're at the beginning and you want to go back, it'll tell you like you're at the beginning, you can't go any back. And if you're at the last, you can't go any forward. It'll tell you that. Also, one feature that we added is a downloadable CSV file. So that means that we pass that object, convert it to a JSON, and that when you download it, you get the respective images X and Y points. So here it is upon first look. We use Bootstrap and jQuery to get this outline. So we start with image 1. Again, if you try and go back, there are no live images before this point. We iterate through. We see that there are 20 different images, and then we're about to get to the end of the image stack. So when we add points, it changes dynamically here. And then those objects are preserved. Also, when you click download, we see that it's here as well.
Yeah, going a little bit more off of that. I don't know if I can go back to the
Oh.
demo.
Oh yeah, hold on.
Yeah, we also implemented a basically ignore and restore feature where if we wanted to ignore a certain image, like the image didn't turn out well for some reason, then we could use the ignore feature. So right now, we just ignored image number 20. So if we go to 19, for example, and then we try to go to the end, basically 20 doesn't exist anymore. So when we click the right arrow key, it, because it's ignored, it doesn't show up. If we want to restore the image, then we can press on 20 up here, and then press restore. And then when we go back to 19, and then we can access 20 again. So,
Okay.
yeah, so these were some screenshots of our web app. And now,
Bless you.
looking ahead, there's like much more improvements we could do. There's many different things we can expand, add new features. And one way we helped implement like the easy way to add more features is we created a new object, and this object had like the points of the point click coordinates in it. It also had whether it was ignored or not. So basically, because we created an object, it's really easy to add new features. So like in comparison to last year's Cosmic Bulls like code, we looked at it and they had they didn't really have a object, so they had a lot of arrays of a lot of data. So we decided to create an object to make it much more easy to add new features in the future.
Yeah, thank you for having us.
Are there any questions of the team?
So for
Wait, watch out.
I got it.
Could you go back to your demo real quick?
Yep.
So is that a zoomed in version of the image, or is that the?
You could actually zoom in on your own. We didn't implement that, but because we forgot to mention, since we use Bootstrap, it's a really responsive web page. So if you do Control+ to zoom in, or if you use your mouse pad to zoom in, it still correlates to wherever on the canvas you want to click, rather than like you click like one here and then it clicks the other if you didn't make your web page responsive.
I was just asking because if you could go back to your slide, could you go to your, I think it's the sixth one.
Second one, right?
Second one, sorry. The image looks a bit larger.
That's, yeah.
So is that one of the images that's within the demo?
Mhm.
Okay. I was just asking. It just seemed like the image was maybe cropped.
Well, the demo was just showing like
Yeah.
example images.
Interesting point.
Any other questions? All right. Thank you.
Cool. Thank you for having us.
All right, the goats. Oh, all right. What's that? Battery life.
Yeah.
Come on, Derek.
You don't watch like you.
Wow, I didn't even see that one that time. I thought I was stepping over it, you know.
Zoom session and share your screen.
I am sharing. Is that off?
Yep, I see it.
Oh, let me see. Can I make that larger? No. Is it fine that size?
That's perfectly fine.
Okay. All right. Hello, everybody. My team name is Graphic Observation and Analysis Tool, and the acronym stands for GOAT. So my name is Edsel Norwood,
I'm Kevin Benton Jr.
I'm Derek Morris Jr.
And I'm Walter Aspel.
and our mentor was Mona Wong. So the problem we were faced with was to create an efficient way for scientists to observe and analyze not only the entire stack of an image. Usually with scientists who are analyzing images, they usually tend to have maybe gigabytes or terabytes of data. And that data will be stacks of images, and it's really not efficient to go through each one of those images single and to pull out some type of data or to analyze it that way. So we were tasked with creating an easy tool to use for especially scientists who aren't familiar with computers to help them analyze and save any type of data that they want from any image. So our solution consisted of using previous year's code, and that was basically for time efficiency. The previous year's code was pretty basic. It was a simple demo, so it wasn't too hard to kind of reverse engineer and use it to our advantage. Also, we wanted to improve functionality, add some features. We wanted to just improve the overall running. There were some features in the last year's demo that didn't really quite work too well, so we wanted to really fix those, as well as polish the UI. Last year's code didn't really have too much AI or too much UI. So this is a before picture. This is last year's code. As you can see, there's no type of CSS or design to the page. It's very bare bones. And also you can see in this picture that the photo is actually, we learned that the photo is a lot larger than it appears in here. And this was one of the issues with the previous code that we had to kind of fix. And here you can see after our improvements, we added several features as suggested by Mona Wong. We added a carousel effect, which pretty much, on either side of the current image you're viewing, it will display the previous and the next image. And that's just for easy readability and so the scientists kind of keep track of where they are. We've also added several other features that I will get into during the demo. So as for kind of the work, I'm going to go ahead and turn it over to Kevin, and we're going to kind of go over what type of work we were responsible for.
So I was really responsible for just revamping the website and adding CSS code to everything. And so I'm going to pass it to Derek.
Okay, so I'm responsible for creating JavaScript functions and adding new features such as the download marker as a text. So on the map, you see that we have red markers. Each marker has a data set to it. And I created the zoom button and the pan button as well.
And similar to the UI conversion, and the program was a little unrefined, and some of the code was a little clunky, so we had to kind of reverse engineer a little bit of it to accommodate some of our HTML element changes, as well as some of our design changes.
And I was pretty much in charge with making sure each function is called properly. Everything is kept in the right place. We did need to create some global variables. We needed to create several functions in order for this to work for the purpose we intended it to. So my job was to make sure each function, HTML, all the elements, the CSS, the UI was properly implemented. So now we're gonna go to, now we're gonna go to the demo. So here you can see we have the demo open. It is currently on the first image.
You can switch your share.
Gotcha. So here we're on the first image, and as you can see, as I stated before, that the previous version didn't show the entire image. You can see here that this is the uncropped image. So if you hit down here, forward image, we can go through each image. All these buttons are still responsive, and we were actually able to add a zoom in and zoom out feature as well as a pan feature. And that was something that was particularly tough because we had to do that in complete CSS. So yeah, that was definitely a journey. But as you can see, we got the zoom in. We can both pan right, left, down, and up. And when you switch images, it'll automatically reset that aspect ratio. And that way, the user can zoom in anytime they want and select that area, get the dots from that, or get the data from that area, and pretty much use it in any way possible. And also, if you can see here, we actually have a download button. And what that does is it will save everything as a text file, and it'll output that to the user. So therefore, the user can see exactly what X and Y coordinates that they have used or they have selected, and they can see the image for those specific points. And also, we also created a custom data structure, and that is to preserve the dots for each image. So that will make it to where when you add dots to a certain image and you leave that image, you can come back and the dots will still be there, the data will still be there, and that's all preserved. We also got the slideshow working, and the slideshow actually works along with the dots. We can play backwards, and you can see right there just past the slide that we had the dot set to. Also, we have a button that removes all the markers. So if we go forward back to the slide, just remove all the markers. That removes all the markers, and it kind of makes it easier for the scientist to maybe start over or disregard the markers on a certain image. Where did my... Oh, there it is. Right.
Yeah.
Can you see it? All right. Any questions? Yes.
Marker removal, that remove the markers for a particular slide that you have to be zoomed on, correct?
Yes.
Did you have a global one, or is it operationally relevant to delete all the markers on all?
Not at the moment. But that would be something definitely easy to implement.
Mhm.
Yes.
So, are you guys able to, like, because I saw there was the little icon bar on the bottom.
Yes.
So you're able to just press on, if you just want to go to like picture 19 or something, you're able to go to that.
Actually, not at the moment. We have that disabled. We were running into issues with when we delete it. It still has to keep up with the index. And again, we were using last year's code, so some of the things that they did with that bar was a bit wonky, but we were working on a way around that.
And then the second question is, I see there was a delete image button as well. And so let's say you accidentally delete that image. First of all, does it ask you, are you sure you want to delete the image? And second of all, are you able to recover it if you accidentally delete an image?
No, we actually didn't implement any type of recovery. And as for the confirmation, that would be super easy to insert within that actual function that deletes the image, but we did not implement a restore. Any other questions?
One more. I have a question about actually being able to add more images into the actual data set. How would you actually be able to do that?
That was something that we were actually looking into. The unfortunate part is we don't have a server to run this on, but we were going to add an upload button. That way you can add to the list of images or just completely upload your own list of images.
My second question is, what is the significance of the data points?
The data points, from my understanding from Mona Wong, it's to send data to a server or send those points to a server. Some type of action is going to be done on that data within that specific area, and then that data will be brought back to the user. But again, we don't have a server, so we have pretty much a mock-up just showing the actual X and Y points. Sure.
Are you using are you making API calls to get the images and save these points on the images, or it is everything is on your? I mean, everything is front end, and you're just saving in the file for now.
Yes, that's another thing for the server. Yes, every image is local at the moment, and the points are local.
All right. Good job, guys. All right. Up next, Cloud Busters. All right, don't forget to go ahead and connect to the Zoom session, and also watch your step. I don't want to lose anybody by mistake. Seriously, John, you're kind of important. You have the laptop with power. And don't forget to hit mute. I was wondering. I'll just leave this back here. Right. Watch your step.
Someone's hidden.
Yeah, literally.
Start at the beginning.
I think
Yeah, I'm about to. I was just.
Yep, it's right by you, Jeff.
Damn, my hand's shaking. That's crazy. Okay, so my name is John Senegal.
My name is Justin Salgado.
My name is Pablo Calix.
And I'm Michelle Reyna.
And our mentor was Boyd Wilson. And our
I'm so sorry. I need you to select your. I need you to select the chair for your presentation. Sorry.
No, you're fine.
Oh, I'm sharing the wrong
Yep, that's
thing.
you.
I'm sharing the wrong thing.
Just show your desktop that way you don't gotta keep going back like you did.
Alright, yeah.
There you go. Perfect. Thank you. I'm so sorry.
Oh no, that was my fault. We're the Cloud Busters, and so our project, we named it Proton Job Pack as a reference to Ghostbusters, and so our idea was to create a job management UI for HPC jobs. Specifically, we used MPI Prime for this one, and the idea was to be able to monitor and be able to submit. And so we were using Intel Power clusters with Cloudy Cluster for the Google Cloud platform. The scientists' idea was like, we don't want them to have to worry about coding all of this. So we were trying to make it very simple where you could go on a web UI and you can manage your jobs yourself, and you don't have to go into the command line and go through all of those kind of steps. And that's kind of how that was our idea.
All right, for our milestones, we understanding HPC jobs submissions, creating a working submission, managing jobs, making it look pretty, and also adding HPC job submission options.
But what actually happened was is that we had took probably that whole first night and a little bit into the second to just kind of get an idea of what an HPC job submission was. Because even Jamie would ask us like, "What kind of job?" and we were just like, "Oh yeah, no, it's just a job, right?" But we had to understand that's for MPI, MPI Prime specifically, and so then after we got to that step, then we had to create a working submission that we could put into our UI that would actually create the job, and we had to pick the scheduler, so we had to choose between Torque or Slurm. And so then we ended up getting able to make a live updating job queue that used jQuery, right? Yeah, jQuery that keeps refreshing. When you submit a job, you can see it provisioning and you can see it creating. And even if you're deleting a job, which I put later, we created a button that allows you just to delete a completed job. And we also updated the web interface.
So then, I'm pretty sure you could tell this is mine. I like to decorate it. For me, it was a bit difficult because this isn't my major at all. So having such an amazing team like John and Raina, I'm so sorry, is just like a really great support. They were with us like 24/7. My amazing mentor as well, Aisha, she was amazing as well for staying with me and helping me learn how to use the scrolling down bar, adding columns, and then as well as adding the website and even adding images in the background. So it was just like an amazing support to have them as something that is something that I ended up learning, ended up, pushing through. So it was an amazing experience to have.
And yeah, there's some functionality on this side still, but did you want to keep on?
Oh no, okay, I'm sorry.
Yeah, there's some functionality like this. The delete job because of the command line command. Actually, you need the job ID to delete the job, so it allows you to insert your job ID, and you'll see in the demo. And yeah.
So this is more of our architecture slide. Like John said, we're using Cloudy Cluster, taking advantage of Google Cloud Platform. And basically, we were able to SSH into the login node, which was able to communicate with the scheduler, the spin up compute nodes. So that was our whole thing. We had to set up a server, get kind of hacky. We did a bottle server with Python. And we did just some local host work to actually test against that server.
So what I learned was mainly pushing through with the web server and kind of using the Visual Studios to write in the codes and kind of learn how to like maximize an image, minimize it, add the scroll bar, and even upload it to the server, which is pretty great.
So I kind of piggyback behind Jocelyn. So for the most part, we kind of like did that a little bit together. It was pretty hard. I mean, it looks pretty simple, but I mean, yeah,
Yeah, and kind of to piggyback what Pablo said, it looks very simple from the front end, but from the back end, there's actually a lot happening. For example, I know a lot of HPC folks might be familiar with some of the QStat and QSub commands. And so in the cloud, it's a little different, but just to keep the naming conventions similar, the naming convention to developers is CC QStat, CC QSub. And so one of the problems we faced was we had to get that from the server back to the web page, but it was getting parsed into plain text, and we really needed that in JSON. There was a lot of noise in there, hyphens, all type of things. So we had to create a JavaScript wrapper or JSON wrapper to wrap those commands and get everything back into JSON before it returned to the UI. The front end.
And yeah, I don't want to say piggybacking again, but so supplementary. So yeah, definitely trying to work with Python and HTML in the background because you have to work with both of them for the web interface. And even like they said, like even something as simple as like a delete button. Well, you have to do a sub process check output just so you can even get there, and then you had to get the job ID from the web page, and sometimes it wouldn't like format correctly, and so we had some trouble with that. And so we had some future steps that we wanted to add because when you start digging into it, you start saying, well, it would be way easier if you had this or you had that. And so even something like the job, like the names right now, they just kind of store random temporary names. So it's like some random string. And so it would be way easier for if someone was trying to manage it, they could have labeled their actual job name instead of having some, have to memorize the job IDs because, you could have up to hundreds of thousands of jobs. And did you have?
Yeah. We also some other things we could do is maybe edit in jobs. Where their current, I guess, where they currently are in the queue. Maybe the ability to stop a job. We have deleted job, but stop, pausing jobs, rerun them again. Just some UI things could have been touched upon as well. Yeah, I would say it's probably some more things, but that's what we got on top of my head. But we'll show you the demo now. I'm trying to get there.
Yeah, it is. Escape.
So it's very simple, but here as you can see.
Yeah, explain why it don't look right.
Oh yeah. Okay, yeah. So because of the server and we couldn't use all of Jocelyn's beautiful UI, but we needed static routes basically. Well, we needed to serve static files through Bottle via Python, and you had to set up all these static routes. So I spent all night really learning how to do that, and it was pretty late by the time I was able to do that with some of her files. So this page is actually a static one, and some of these elements actually serve statically, but I couldn't do the CSS earlier today. But you can't really see it, but this is actually refreshing every 10 seconds. So if we were to submit this job, it would actually, well, we can do it, but it will actually join, append onto this job queue. And here is the actual script, is that MPI script John was talking about. You can touch more on it.
Oh yeah, so we decided to do the Slurm scheduler, and where's the nodes at? Okay, yeah. So then we did our 4 nodes, and then do the task per node is up at the top. And so what we were talking about, some of the future steps would be instead of having someone having to copy and paste their script through there, you would be able to have input boxes for the number of nodes you wanted or the number of tasks you wanted per node, which would make it much cleaner than this.
Even uploading the JavaScript would be a little bit easier than just copying and pasting.
And so then, that's really small. But this is the text box for the deleted job. So I just had to pick one of the random IDs, which is why the live queue is so important because you would have to go to your command line CCQ stat just to even get a job ID. And so we'll just do the top one. Come on, bro. And then there's a prompt because obviously you don't want to just delete something. Right? Even though you're typing in the ID, maybe one number off if you have thousands of jobs could be damaging. Okay. So it was working earlier, but as you guys know, I'm sure that stuff goes left. But yeah, that's basically it.
Could you refresh it just to?
The queue's gonna take it takes like a couple minutes for it to load back up. Yeah. And so I'm gonna go look at that, but yeah, that's basically it.
Were you trying to kill a completed job?
Oh yeah, only completed ones right now. Because we wanted to add the ability to be able to pause a job, so all the provisioning ones you don't want to delete them in the middle of provisioning and stuff like that.
I was wondering if you did any literature review or any research on existing interfaces to do things like this.
So I currently actually intern with OSC, and we have a project called On Demand, Open On Demand, and so that's literally like our product is a job submission, job management UI tool. So I guess I have some knowledge just building that platform and building on that, but no real academic research or just kind of yeah.
Yeah, because none of us had because he was the only one with any HPC experience at all. So we really went to him and definitely Mr. Boyd, and Mark actually. Yeah, Mark helped us too, and so it was mostly anecdotal.
So what did you think about using the Cloudy Cluster product?
It was actually fairly seamless. Like it was never really a hassle to use Cloudy Cluster. I've had some other, I guess, experience with other cloud computing platforms, and it was pretty seamless compared to like OpenStack and other things. So I would actually recommend it to people.
And after you learn the commands and tags, it goes pretty quick. After that first night, it went pretty quickly as far as getting the commands. It was more like just getting the UI and the commands to be able to connect.
I will say, I guess like it could use it's missing some traditional features that most, I guess, like HPC specialists might need, or anybody working on the command line. But I guess that's coming still. Yeah, they're still working on it. But there's just certain things and certain bugs still in the program, so that was also kind of something we had to worry
That's why
about.
it didn't work. It was a bug.
Let's say that. No, there's certain things like timestamps and things would have been very useful. It's a lot of things that would have been more useful. Even the CCQ stat only really showed those 4 categories, but maybe more data could have been spawned. So yeah.
So I'm curious, it sounds like you guys learned a lot about HPC. Is this a field that you think you might want to stick with or interested in for perhaps something else?
Well, yeah, I was kind of interested in. I'd never really seen anything like it before, so I'm always willing to dig more into stuff before. Especially like I wouldn't make that decision after just 4 days of trying to learn it at like 9 a.m. till 12 or something. So maybe at a different, longer term learning style, I would be more, even more into it. But I'm pretty into it now, so there's definitely some more I can learn about it.
Yeah, I agree, and I'm a biology minor. I love science, and so like this is the perfect kind of like in between for me, where I could do some programming, some problem solving as well as like engage with scientists, and help them solve problems as well.
For me, I would like to kind of like take more of the time to kind of figure out more programming, and because I know it's not my field, so it would definitely be like more interesting to have more time and have like a mentor like Aisha to like kind of push you through and like take it step by step. But I had a lot of fun and I enjoyed it.
And then for me, I feel like the more information I can have on just about anything is like the best for me. So yeah, I'd love to learn more.
Any other questions? Good job. All right. Last but certainly not least, jams.
Where is
Don't forget to share your.
Yep. Can you take out?
So as they're setting up, I just want to put out there one more time. There are sheets going around with the QR code and the website where you can vote for your favorite team. Voting closes at 6 o'clock sharp. So please vote for your favorite team.
All right, good afternoon, everyone. My name is Mel Mishiku.
I'm Shivam Rastogi.
I'm Arushi.
I'm Jelly Chung. And at the PERC 19 hackathon, our team were lucky enough to use the distant reader to solve a problem. So we're gonna first talk a little bit about distant reader. Distant reader.
Just want to say our mentor is Eric Morgan. He's sitting there.
Yeah.
Thank you, Eric, for all your help.
So I was gonna introduce him in the next.
Oh, okay. Cool.
Okay. So our problem statement is the incredible thing about Distant Reader is it's a tool that takes unstructured data and makes it structured. And when we saw that, immediately, like, my heart skipped a beat. I was like, this is incredible. And I wanted to see what I could do with it. And the simplest thing that came to mind is if you're used to reading a large corpus of data, let's say you have to do a lot of literature review for medical cases or anything like that, or if you just want to augment your learning, whether you're a literature major and you just, let's say you've never read Homer, that's a hint, we're going to be looking at Homer a little later. This gives you a structured representation of all of that data. So basically, after knowing that problem, we wanted to create a mnemonic representation of all of the data that Distant Reader gives you. So Distant Reader has a few specific vocabulary terms. So a study carol is the post-processed work or data that Distant Reader gives you. And in a study carol, there are different things like parts of speech analysis. It gives you frequencies, things like that that allow you to really understand what the corpus does. And so we just wanted to visualize and glean insight from all of that data. Next slide, please. So as I said, our goal is to use the text corpus to create a meaningful graphical representation by taking the data, making it structured, and then graphical representation. So
these are some of the technologies that we've used. So for the data manipulation, we've used Python, Pandas, and NetworkX. And for the front end, we've used D3 JavaScript library for representing the data in a graphical format. And we've used Flask for building our web application. And Node2Vec, I think you're going to explain about that. And all of us were coding in Google Colab for better collaboration. Yeah, you can go ahead.
Okay. Yep. Yeah, you want to.
Okay, so after we built the knowledge graph, since we're here at Perk 19 and the theme is the rise of machine learning, we wanted to see how we can also incorporate a little bit of machine learning features into the Distant Reader Science Gateway, allowing anyone who has unstructured data to also be able to run their own machine learning algorithms, their binomial learning algorithms. And so we did that by first, of course, creating the knowledge graph, and then using Node2Vec and creating our own pipeline so that we could have a vectorized representation of our graphs. And this is really crucial because normally if you have just normal data, let's say a lot of Twitter text files, you're able to use Word2Vec to only get contextual meaning. So you can do sentiment analysis and all of that. But our pipeline uses graphical representations. So what that does, it's also relational. So it can do what Word2Vec can, and it has a lot more features as well.
Okay, time for demo. So for the demo, we are going to show the web application, and then we will walk through the Jupyter Notebook because most of our processing was done in Jupyter Notebook. Okay. So this is just a short intro about Distant Reader, and this image is just a word of clouds that we have extracted using Distant Reader. So all this is already present in Distant Reader. And this is our knowledge graph. So what we have done here is taken Homer, run it through Distant Reader, and then we have taken the unstructured data to structured data, and then we have created this knowledge graph. And can you walk? So he has read Homer. I think I haven't read. So he's gonna show how it actually relates, how we can find insights into data.
Yes. So Jali pretty much did a lot of the NLP processing, and so if we look here, Jove is one of the main nodes, and that's just another name for Jupiter, but or Zeus in this case. And then one thing that you can always tell is Menelaus is related to Troy, and you've got the Argus. You've got everyone related to you have people who fought in the Trojan War together. You have Leonidas, different kings everyone's relationally linked with a pathway connected to Troy, because that's where they all fought. And then a lot of the relationships you can see if you've read the book, but we were very happy once we did that. And we did that with weighted node vectors, which Jali took a really long time of figuring out the proper way to distinguish the information between nouns. And he did that in pandas.
And so just to add, like the size of the circles here show how many connections are coming in or going out. And
yeah. And actually, you can see that Ulysses, he's related to the suitors, his house, attacks. No spoilers, but it's a great. So you should read it.
Yes. Not working.
And so the next thing we did is we also took the Bible.
We tried. It's only the New Testament because the whole Bible was taking too long.
Yeah.
But I think we need to clean up the data. But you can see the biggest words are God and Jesus.
Yeah. So Jesus, if you pull his bubble, a lot of things move. You've got the disciples, the books specifically, and how they're linked. Jerusalem, you've got your geographical features that also just help you glean insight just by looking at it. And that was our whole what we really wanted to do, so that
So
if you're
we
a
can
reader,
probably zoom in and see some of these items. Yeah, but I mean, we have to further do more and use more NLP and like try to remove
and clean it up a little bit.
Outliers or stuff that do not give a lot of information. Then we have some more.
So the next one.
So we just took a block from on machine learning and tried to run. I mean, we did not read it. Don't read the whole blog, but it says, for example, it was describing a paper, and then it says like the conference is ICML. It was held in California, and it is a machine learning international conference. So all that information is there.
So basically, you could see Southern USA, California, and ICML connected together, signifying that the conference was held in California.
Yeah. I think we can this is one more. This is Aesop's Fables.
Yeah, and I think the only one I remember from my childhood was the tortoise and the hare. So we have to.
Cannot find it.
In the middle.
In the middle.
Cannot see if you see the red crow to the right.
Yeah.
Okay.
Eagle. Okay. Yeah.
Yeah, so the tortoise and the hare are linked there, and the is
the tortoise. Yeah. Okay, so I think this is pretty much our web application, and we have some features like you can zoom in, zoom out, you can move it around, focus, and sometimes it just goes away. But it took us a lot of time to like bound all these, so we had to learn D3 JavaScript library for doing this, and like it was quite challenging to like add all these features like bound the data so that it does not goes out of the box, and then zoom in and zoom out. So we are quickly going to walk through the Jupyter notebook that these guys have been using for NLP and network X processing. Yep.
Yeah, so literally what we did here is we made it really simple to the point where later you'll be able to pretty much say choose your study Carol, which comes in a zip, and then it will, in this case we're just downloading Homer straight from the Distant Reader website, and then we unzip the study Carol, and these are all the things inside, and then we clean it a bit, and then we get our tokens, we get our weights for the graph, and then we're able to this is the word cloud, and then this is a network X representation of the whole corpus, and so that's what we use, and so from this point on we start facilitating machine learning for the whole thing. And the way we did that is we abstract our whole graph by using node to vec, so we vectorize everything, and then we create a model that embeds everything, and after we do that, this is more about just visualizing everything. So for Homer, I used Jove as the main thing, and that's what we're going to be contextually. We're going to be using a t-distributed stochastic embedding, basically. And then to do that, this is the whole map, and Homer ID is Jove, so Jove is that blue dot there in the midst of everything. And with more time, we could kind of create better representations of different subject areas within the whole corpus, but we quickly just wanted to figure out how to be able to have a machine learning model run on top of the study care. Yeah. And so that's pretty much that part.
So going back to our presentation.
So yes, these were some of the goals that we wanted to accomplish, but we were not able to completely complete them. So one of them was adding more functionality to our knowledge graph. So maybe the user can click the node, and we get more information about that node from knowledge databases like ConceptNet and DBpedia. But we realized setting up ConceptNet and DBpedia is quite hard, and it takes a lot of time, so we were not able to complete that. Other thing we would like to add to our Flask web app is to add the functionality of keyword search. So the user maybe can search for any node, and only that part of that graph will be displayed. And we also wanted to add some more data sets to our web app. So yeah.
And then for distant reader ML portion, we wanted to have a demonstration of a biomedical network. So we didn't really get enough time to find the literature we wanted to demonstrate for that, but that's a possibility.
I just want to really thank Giali because
Yes.
I mean a major part of the backend was done by him, but he had many other presentations and events to attend, so he was short of time, but he helped us do all that.
I'm very happy to work with the three excellent designers.
So yep. So do you guys have any questions? Yep.
Was there any significance to the colors of the nodes?
Oh, they are random for now, but what we intend to do is if we have clusters, so we can give we can give the nodes according to the clusters, but right now they are just random.
And you have lines in between the circles to represent some relationship.
Yeah.
Is there any information about what that relationship is?
Right now it's pretty naive.
Okay.
So since we're doing this in only 4 days, so right now we count if two words appear in the same sentence, we consider there's a relationship between them.
Okay.
So there are also other popular ways to do that. We did a lot of literature review. For example, you can use dependency parser to parse the syntactical and semantic relationship between two words in the same sentence, and that's one way. Another popular way is to use deep learning. For example, you throw the sentence into BERT, and it will output the relationship between token A and token B. So that's the two popular ways to get the valid relationship between two words in natural language processing. So, but in our case, we're only counting how many times two words appear in the same sentence. So maybe in the future we're going to upgrade this.
Yep.
So did you guys think about I'm guessing you guys thought about at some point about filtering the words so there wasn't so many words at once, and you're able to get a certain aspect of the relationship, or maybe just lion or something like that, or even just some of the small outliers out there.
So we did think of that, but in this case, we just wanted to first have the full graph, and then you could kind of have node segmentations later by implementing your own, or we could implement a future filtering function.
Eric gave that idea, like to give a text box, and you can add, oh, I want to just see lion, like what are the things related to lion in the Aesop's fables, and then it will pick out all the entities that are related to it, so we can focus. You can focus instead of having a very large network. Yeah.
How long does processing take? Suppose you've already got a study, Carol, okay? And now it's on my file system, or it's on a server, or whatever. How long does it take for you to say select it and then make a graph?
So I think the New Testament, Bible's New Testament, it took around 20 minutes.
It took around 15-20 minutes.
15-20 minutes, and it has around 180,000 words, and
That's single core.
Yeah.
Yeah.
The next question would be, to what degree from your experience could that process be parallelized?
That could be easily parallelized because the processing